word problems applying what we have learnt. There are a couple of terms that you need to know in the little table that's there. An angle of elevation is an angle from a horizontal line going up. So here's our horizontal line here, and it's the angle coming up from there. So that angle in there, which is what we call an angle of elevation. An angle of depression, the next one, it also starts with the horizontal line, but it goes down. Okay, so we need to be aware of this angle of depression going down from there.
What's it called, an angle of depression?
I know it sounds depressing, doesn't it? Not really sure why they gave that name. So here is a little diagram. Often when you have an angle of depression, it is because somebody is up high. So here we have a man standing up on the tower, and the angle of depression is from his horizontal. So here's his horizontal line, and it's the angle going down. Now that angle, guys, pay attention please. That angle up here, this angle of depression, is not in the triangle. See the triangle that's been formed here? Okay? But one little geometry rule will solve all of our problems. In geometry, do you remember alternate angles? Does that name sound familiar?
Yes.
So alternate angles are a Z shape like this that are formed on parallel lines. And the rule tells us that this angle here must be equal to that angle there. So usually as soon as we see an angle of depression, we just go, oh, alternate angles, let's put it in here in the bottom of our triangle. Okay, so we're going to be doing that. So here is our questions. They're word questions. So your first step should always be to try and draw the diagram, because that's the only way we're going to know where our opposites, adjacents, and hypotenuses are. Okay? So, from a vertical cliff 80 meters high. I don't expect you all to be artists. So often when I say a vertical cliff, I'm just going to draw a vertical line like that. There's my vertical cliff. Clayton, unhand the chair. Okay, booklet open. You're not even on the right page. Booklet open, and it's time to start writing this down. So there is my vertical cliff. It is 80 meters high. So I put that number on straight away. And so far, all I've done is read those first 7 words or 6 words in a number. Okay? The next part says, the angle of depression of a boat out at sea is 15 degrees. Okay, so I've just read the next little bit. So somewhere out to sea. Now, if I'm standing on a cliff, then the cliff is going to be above the water, and this is going to be my water across here, right? Okay, that should be a horizontal line. I didn't deliberately make that wavy. Okay, and down here we have a boat. Now you can just draw a dot for a boat. If you're more artistic, hey, maybe you want to draw a little boat. Here it is. There's my little boat. The angle of depression, which means I'm going to join up my triangle. There's my triangle joined up. I'm on the top of the cliff. The angle of depression, remember, is measured from the horizontal line. So it is in there, 15 degrees. Okay, from the top of the cliff, you find and draw the horizontal line, and the angle of depression, which means going down, is 15 degrees. But that other little diagram that I showed you means that as soon as we have this angle in here, we go, whoop, alternate angles, I'm going to put it down here. Because that angle and that angle, they form the Z shape, which is alternate angles, they are equal. So I'm going to go 15 degrees down here. Okay. The next little part, I've only read up to here so far. What's the next bit say? How far is the boat from the base of the cliff? Okay, I'm trying to find boat here, cliff here. I'm trying to find how far that is. Okay, let's give it a letter. Let's call it X. Okay, and there is my diagram. It does say here, which I haven't read yet, answer to the nearest meter. So that's how to round it when I finally get my answer. Okay, ready for trigonometry time. I've got an angle. I need to know what these sides here are called. Oh, by the way, there is one more thing I did put on my diagram. This one here would be a right angle. If you have a vertical cliff and the water, that's where your right angle would have to be. And they do always have to be right angle triangles when we're using our SOHCAHTOA. So, 15 degrees. The 80 over here, what's the name of that side? Is it the opposite, the adjacent, or the hypotenuse? Opposite, correct. So let's put an O over here. That's the opposite. What's the X called? Adjacent, correct. So, which rule am I going to use? Sine, cos, or tan? Tan. Okay, remember your SOHCAHTOA. It's always good to just have it on the top of your page or somewhere where you can see it. Okay, so the O and the A is for tan, T for tan. So we write the formula down. Tan theta equals O over A. Then we sub in. The theta is 15. The O is 80. And the A is X. Now in these word questions, you're going to have a combination of some questions are going to be finding sides and some of them are going to be finding angles. And we've done both of those different types. This one we're finding a side, right? So I've got an X in here. And I need to get that X by itself. It's on the bottom. What happens when the X is on the bottom? We're going to divide, correct. So the X comes over here. The 80 stays exactly where it is. But the tan switches places and is on the bottom where the X used to be. It's the switch place one. Then you grab your calculator and you type that in. So, fraction button, 80 on the top over tan 15. That's a normal tan. You only use the inverse tan if you're finding angles. So, normal tan of 15. And it said, remember, nearest meter, which means I don't want any decimal places. So this is a 5, so am I going to round up or down? Up, which means my answer is going to be 299. So 299 metres. The boat is 299 metres from the cliff. Easy peasy, right? It's all about getting that diagram right. Then the trigonometry should all be familiar. Yes, Will?
My fraction one doesn't work. I express it in control of that.
It's a city. I can change it. There you go. All right, let's try the next one. Question 2. The angle of elevation of the top of a tree from a point on level ground 10 metres away. All right, let's break that into sections. We have a tree, okay? Just like I had a vertical line before, a tree can totally be a vertical line, right? There's my tree. If you want to, please feel free to, okay, here's my tree, lovely, okay? You can be far more artistic if you want to, but this is not an art class. There's my tree, okay? I have a point 10 metres away on level ground. So somewhere over here, across some level ground, which means there's my right angle, 10 metres away from my tree. Yeah? Now, let's read through it again, because I haven't done everything from the question so far. The angle of elevation of the top of the tree from a point on level ground 10 metres away from the base of the tree is 19 degrees. I know that is wordy, so here's my triangle. It said angle of elevation. Remember, elevation means horizontal up. And it said, from this point, standing over here 10 metres away from the tree, the angle of elevation to the top of the tree is the 19 degrees. So that means that angle there is the 19. Okay? It's only the depression questions that are outside that we use the Z shape to bring them in. Okay, find the height of the tree to 2 decimal places. So this vertical line was my tree. I'm going to call it H because it's a height. And we're ready to do our trigonometry. Let's label our sides. The H, what's that one going to be? Or maybe I shouldn't have called it a H because, yeah, it's an opposite. That's an O. And what is the 10 metres? It is the adjacent. So what rule am I using for sine, cos, and tan? Tan again. Good, yeah. So tan theta equals O over A. Sub in. We have tan of, what's my angle? 19, good. Equals, what's my O? Nope. H, the H, yes. And what's the adjacent? 10. Okay. So I've subbed in, my H is what I want to know. It is on the top. What do I do when H is on the top? Times them. So H equals 10 times by the 10, 19. Calculator time. 10 times 10, 19. So it's said to 2 decimal places. So 4, there's the 2 that I want. The 3 after that will round down. So 3.44. Okay, so my tree is 3.44 meters. So I put an M there. It's meters tall. Okay. That's actually the only ones that were in the examples. That's the end of my examples, and there's your practice ones. So it's all about getting that diagram right, and for quite a few of them I have given you the diagrams to get you started. Please be aware that there is some in there where you have to find the angles. See this one in here? Find the sides of the angle. So they're the ones where you're going to have to use inverse sine, cos or tan to find those angles. Okay, I'll help you with those when we get to them if you like. So start with question 1. Diagrams there for you, see how you go.